You're listening to DTFHN for May 4th, 2026. I'm your structurally unsound host, Jack Haxman. We are your daily tech feed for Hacker News, a website where mass delusion meets footnotes. Today's a day for squinting at the math and wondering who thought we wouldn't check. Let's get into it. Let me make the strongest case for this deal. GameStop has $4.8 billion in cash and Bitcoin on its balance sheet. Ryan Cohen turned Chewy from a scrappy pet food startup into a $40 billion company. eBay is a marketplace that's been coasting on brand recognition for a decade, leading sellers to Amazon and Shopify, with a bloated cost structure that's begging to be cut. A visionary operator with capital, a commitment letter for $20 billion in debt financing, and a thesis about combining physical retail with online commerce. On paper, you can squint and see the logic. Now, let me tell you why this falls apart on its own terms. GameStop's market cap is $11.9 billion. They're offering $55.5 billion for eBay. The offer is $125 per share, half cash and half GameStop stock. Run the arithmetic. To pay the cash portion, they need roughly $27.5 billion. They have $4.8 billion. The TD Securities commitment letter covers $20 billion in debt. That still leaves a gap, and the stock portion requires GameStop shares to hold their value through a deal that would dilute existing shareholders into oblivion. As one commenter noted, the math is literally impossible under the stated terms. The question nobody in the financial press seems willing to ask plainly: is this an acquisition proposal, or is it a press release designed to move stock prices? Look at the incentive structure. Cohen's compensation at GameStop is tied entirely to hitting a $20 billion market cap. GameStop shares jumped 4% on the announcement. eBay jumped 13%. The mere act of proposing a deal that cannot close on its stated terms generated billions in paper value. Cohen would become CEO of the combined entity with no salary, compensated solely on performance. Which sounds noble until you realize the performance metric is market cap, and market cap responds to exactly this kind of announcement. Forrester's Sucharita Kodali put it with clinical precision. We are not necessarily putting two strong companies together. The deal would saddle eBay with GameStop's debt. That's not a merger, that's a balance sheet transfer. The Hacker News comments are actually the most illuminating part of this story. Half the thread is people explaining leveraged buyout mechanics to each other, as if the financial engineering is the interesting question. It isn't. The interesting question is whether a public company CEO can use acquisition proposals as a compensation mechanism. Announce deals that can't close. Harvest the stock movement. Repeat. This isn't about GameStop versus eBay. This is about what happens when meme stock dynamics meet corporate governance. The market moved. The math didn't change, and nobody with a fiduciary duty seems to be asking why. Now, one city is actually doing something about the math that doesn't add up. Amsterdam just banned public ads for meat and fossil fuels. I've spent years working on recommendation system, building the machinery that decides what information surfaces in front of people. And the single most important engineering decision in any recommendation system is the same one Amsterdam just made about its bus stops. What do you optimize for? Amsterdam has banned public advertisements for meat products and fossil fuels. Starting this year, the city's billboards, bus shelters, and metro stations will no longer carry ads for cheap flights, SUVs, or chicken nuggets. The council member behind the policy put it plainly. What we display in public space reflects what we consider normal, and the city decided that normalizing the products most responsible for climate breakdown is a design flaw worth patching. Now, run this forward A generation of kids in Amsterdam grows up without seeing budget airline ads on every corner. They still know planes exist. They still eat food. But the ambient assumption that flying to Barcelona for €40 is a default lifestyle choice. That signal is gone. The information architecture of their daily environment has been redesigned. I've watched this exact dynamic play out in software. You change what the default recommendation surfaces, and within 18 months, the entire user behavior distribution shifts. Not because you banned anything, not because you lectured anyone, you just changed what was effortless to encounter. The path of least resistance moved, and people followed it. Every systems engineer knows this. Every ad executive knows this too, which is why they're upset. The unintended comedy here is watching the advertising industry argue with a straight face that removing their content from public space constitutes censorship, while simultaneously insisting that the entire purpose of advertising is to shape behavior. Pick one. Either ads influence people, in which case regulating them in shared spaces is legitimate governance, or they don't influence people, in which case the industry has been defrauding its clients for a century. Both positions cannot be true at the same time. What Amsterdam actually built is an open protocol for public attention. The city decided that shared visual infrastructure, the services every resident encounters whether they choose to or not, should not be allocated purely by who pays the most. That's an architectural decision. And it's the same one every open system eventually faces. Do you let the highest bidder control the defaults? Or do you design the defaults to serve the people who actually live inside the system? Other European cities are already watching. The interesting question isn't whether this works for Amsterdam. It's what happens when the template is open for anyone to fork. We talked about open defaults. Now let's talk about what happens when someone hijacks a trusted name. Notepad++ has a Mac problem. In Amsterdam, the University of Illinois released a web browser called Mosaic when Mark Andreessen left to build what became Netscape Navigator. The university's licensing arm sued over the name and the code's lineage. That dispute established something important about open source that people still get wrong 3 decades later. Open code does not mean open identity. The source can be free. The name is not the source. Notepad++ has been one of the most recognizable open source projects in the world for over 20 years. Don Ho's GPL licensed text editor became the default recommendation for anyone writing code on Windows. Millions of developers know the name. Think cray. And now someone has shipped a Mac application using that exact name, that exact brand identity, claiming to be an official port. And it isn't one. Let's break this down to first principles. A GPL license grants you specific freedoms: the right to run the software, study it, modify it, and redistribute your modifications. What it does not grant is the right to the project's name, logo, or brand identity. These are separate legal instruments. Trademarks. And they exist for a reason even in the open source world. The reason is trust. When a user downloads something called Notepad++, they're making an assumption about who built it, who maintains it, and what's inside. A trademark violation breaks that chain of trust, regardless of whether the underlying code is technically open. What makes this case particularly worth examining is the context. According to the Hacker News discussion, this Mac version may have been vibe-coded, AI generated as a quick port, and when the original project asked the author to change the name and logo, the response was apparently defiant rather than cooperative. This matters because the fix is trivially easy. Change the name to MacPad++, or NPP Mac, or literally anything else. Update the logo. Make it clear it's a community port. Done. You keep all the open source freedoms the GPL provides, and you stop free riding on 20 years of someone else's reputation. Open source only works if trust scales. A developer who maintains a project for 2 decades has earned something beyond the code itself. A relationship with the people who use it. When someone appropriates that identity, even to ship something functional, they're not contributing to the open source ecosystem. They're extracting from it. The code was always available to fork. The honest path was always right there. Just pick a different name. Trust and identity matters, and so does precision, which brings us to a fascinating trick AI models are learning for getting text and numbers exactly right. What does it mean to teach a machine to be precise? This is a question that's been nagging at me since the earliest days of image generation. These models can conjure photorealistic scenes, impossible architectures, emotions you can feel through pixels. But ask them to count to 50, to spell a word correctly. They fall apart like a student who aced the essay portion but bombed the math section. The reason is architectural. Diffusion models and their descendants operate in latent space. They're painting with vibes, not plotting with coordinates. They understand the gestalt of what a number looks like without understanding what a number is. It's like asking a jazz musician to play a metronome. Wrong tool, wrong cognitive mode. Sam Collins figured out something elegant. Think of it like tracing paper in classical painting. Renaissance artists didn't freehand their perspective grids. They laid down the geometry first, then painted over it with all that luminous oil and emotion. The underdrawing carried the precision. The paint carried the beauty. 'Cause method works the same way. Step 1. Generate an SVG or any deterministic image with your text and numbers placed exactly where they belong. Correct count, correct sequence, correct positions. This is the domain of code. Where math is trivial. Step 2. Feed that image into a multimodal model like Gemini 3 Pro alongside a style prompt. Transform this into claymation. Make it look like artisan chocolates. Paint over my sketch. The results are genuinely remarkable. 50 numbered stepping stones in a correct counterclockwise spiral. Something that fails catastrophically with a text prompt alone. The model preserves the spatial relationships and text from the input image while applying its generative strengths to style, lighting, texture, material. What I love about this is the engineering humility. Instead of waiting for models to solve text rendering internally, which they will eventually, you compose 2 systems that are each excellent at different things. Deterministic precision plus generative beauty. It's the Unix philosophy applied to image generation. Do one thing well, pipe the output forward. The Hacker News comments are split between people saying this is obvious in retrospect, and people pointing out it's similar to existing techniques like depth maps and control nap. Both are true, and neither diminishes it. The best hacks always look obvious after someone names them. That's exactly what makes them useful. They become reproducible, shareable part of the collective toolkit. The tools exist. Claude Code, or Codex, can generate your SVG underdrawing automatically. The whole pipeline is automatable. One person figured out the pattern, published it openly, and now everyone can make images that were considered impossible last week. That's how open knowledge compounds. So what happens when you apply that same pattern recognition lens to something the government would rather you not understand? The top-voted comment on this one cuts right to the bone. Quote, "The story is designed to make the public believe that U.S. propaganda is actually aimed at the foreign adversary rather than at the U.S. population." End quote. That's not a conspiracy theory. That's a design pattern with a long pedigree. In 1955, the CIA launched Operation Mockingbird, a systematic program to influence domestic media by planting stories, cultivating journalist assets, and seeding narratives that served intelligence objectives. The Church Committee exposed it in 1975. The agency promised reforms. And here we are, 7 decades later, watching Veritasium methodically dismantle a CIA claim about a magical heartbeat sensor that can identify individuals from a distance. The technical debunking is straightforward, and that's what makes it damning. One commenter who actually worked on UWB radar for detecting breathing through walls notes the effective range was 1 to 10 meters. Useful for finding survivors in rubble, not for surveillance at standoff distances. Another points out that detecting heartbeats from skin color changes in phone video is well-established science. Then asks the obvious question. If you already have video of the target's face, why do you need a heartbeat sensor? You don't. The capability claim collapses the moment you apply basic engineering reasoning. Several commenters converge on the same insight. There are so many easier ways to detect and identify a person that the heartbeat story only makes sense as theater. Clarke's third law says any sufficiently advanced technology is indistinguishable from magic. One commenter flips it beautifully. If a technology sounds too much like magic, maybe it just is magic, meaning fiction. This is the playbook. You announce a capability that sounds barely plausible. Let journalists repeat it uncritically. And now every adversary has to waste resources defending against something that may not exist. Meanwhile, your own population believes the surveillance apparatus is more omniscient than it actually is. Which is the real product? The deterrent isn't the sensor. The deterrent is the belief in the sensor. What Veritasium did here is exactly what open inquiry is supposed to do. Take a claim from a closed institution, apply publicly available physics, and show the math doesn't work. The tools to verify are available to anyone willing to use them. The CIA's magic trick only works in a world where nobody checks. This one's pure joy, a project that teaches programming principles without ever opening a terminal. 5 words buried in the curriculum description: analysis, combination, generalization, abstraction, simulation, not syntax, not variables, not loops. The creators at NHK looked at what programming actually is, underneath the semicolons and the bracket wars, and they found thinking patterns. Then they built a children's show around those patterns. Shedap, Habart, Garaktionet, the way set, and they built one huzz. Let me play devil's advocate for a moment. You could argue this is exactly backwards. That programming without a computer is like swimming without water. You're just waving your arms on dry land. Kids need to feel the feedback loop. Type something. See it run. See it break. Fix it. That tactile cycle is where the magic lives. And honestly, that argument has teeth. The REPL is one of humanity's great pedagogical inventions. But here's where it fails. The feedback loop only teaches you to satisfy the compiler. It doesn't teach you to decompose a problem before you ever open an editor. It doesn't teach you that abstraction. Real abstraction, the kind that makes a system elegant instead of merely functional, is a way of seeing the world, not a language feature. Every senior engineer I've ever respected does their best thinking away from the keyboard, whiteboard, napkin. Walk around the block. The machine is where you transcribe the solution, not where you find it. What NHK built here is a course in computational thinking for minds that haven't yet been trained to confuse typing with problem solving. The animated characters aren't teaching kids to code. They're teaching kids to think in systems, combination. How do pieces compose? Generalization. What's the pattern underneath the instances? These are the skills that survive every framework change, every language migration, every paradigm shift across a 40-year career. One commenter, a developer married to a primary school teacher, said he'd already taught 2 classes using the material. That's the builder instinct at work. Saw a tool, used the tool, put it in front of people who needed it. The show itself is freely available on NHK World. No paywall, no app subscription. Just knowledge, sitting where anyone can reach it. The craft here is in what they chose to leave out. No IDE, no error messages, no gatekeeping syntax, just the architecture of thought made visible for 7-year-olds. That's elegant engineering. We talked earlier about infrastructure you can hold in your hand. Next up, Pause by BYOMesh is pushing that idea even further. 100 times the bandwidths. That's the claim. Let's be precise about what that means and what it doesn't. LoRa mesh networking. The kind of running on Meshtastic and MeshCore. Operates in sub-gigahertz spectrum, 900 megahertz in the US, 868 in Europe. The physics at those frequencies are forgiving. Signals bend around obstacles, penetrate walls, travel kilometers on milliwatts of power. The trade-off is data rate. You're moving bytes, not megabytes. Text messages, GPS coordinates, sensor telemetry. It's radio for the apocalypse, not for streaming video. BYOMesh is pushing into 2.4 gigahertz territory, which is where your Wi-Fi lives. And yes, you can move far more data at 2.4 gig. That's not controversial. It's antenna theory, but you're buying bandwidth with range. 2.4 gigahertz doesn't bend. It doesn't penetrate. It's line of sight or nothing. And nothing includes a single concrete wall in many cases. The engineering question worth asking, what problem are you actually solving? If you need to send a paragraph across a city with a $5 radio and no infrastructure, sub-gig LoRa already does that. If you need to move real data, firmware updates, encrypted channel negotiation, distributed key signing, then the bandwidth ceiling matters, and 2.4 gig mesh starts making sense. One commenter sketched out distributed ring signatures over long-distance mesh links. Redundant nodes across geographic regions forming an encryption channel with no server, no cloud, no certificate authority. That's the kind of application that needs more than a few bytes per second but doesn't need Wi-Fi speeds. The sweet spot this hardware is reaching for. And this lands during a wild week for MeshCore itself. The open source firmware that's turning cheap ESP32 boards into mesh nodes. The entire stack is inspectable. Firmware, protocol, routing logic. Anyone can audit it, fork it, build on it. The hardware costs less than lunch. The regulatory landscape is real. FCC rules around duty cycle and power output at 2.4 gig aren't the same as sub-gig, and the popular protocols haven't fully sorted that yet. Worth watching. But the trajectory's clear. Commodity hardware, open firmware, mesh topology that doesn't need anyone's permission or infrastructure to exist. Communications architecture where the off switch isn't in anyone's corporate headquarters. That's the point. Moving on. There's a beautiful irony in what's happening here, and I want to name it precisely. Anthropic built Claude Code. It's genuinely excellent. The tool, the file editing, the bash execution, the way it spawns subagents and chains multi-step operations, that's the product. That's what you're paying $200 a month for. But here's the architectural joke. They exposed environment variables, Anthropic base URL, Anthropic auth token, Anthropic default opus model, configuration knobs that let you point the entire machinery at a different brain. Someone named Ottern looked at those knobs and wrote a shell script. Not a fork, not a reverse engineering effort. A shell script that set 6 environment variables, launches Claude Code normally, and restores your originals on exit. The brain changes. The body doesn't notice. DeepSeek V4 Pro on the other end, scoring 96.4% on live code bench, serving tokens at 87 cents per million output versus Anthropic's $15. That's a 17N cost difference for what the benchmarks claim is comparable reasoning. The context caching makes it even more absurd. After our first request, repeated context dropped to 0.4 cents per million tokens. Agent loops, which hammer the same system prompt and file context over and over, become almost free. Now, the comments correctly point out several things. The subsidized pricing won't last. The model training might not be optimized for Claude Code's specific tool calling format. Vision doesn't work, and DeepSeek's own documentation already tells you how to do this without the wrapper script. All true. All beside the point. The point is architectural. Anthropic built a best-in-class agent harness and made the back-end swappable via environment variables. Whether that was intentional or incidental, the consequence is the same. The harness becomes a commodity interface. Any model that speaks the Anthropic messages format can slot in. DeepSeek today, whatever scores highest on live code bench next month. The competition isn't between agent products anymore. It's between inference providers racing token costs towards zero. This is what composable systems do. The best tool loop pairs with the cheapest adequate intelligence. The engineers who built Claude Code's elegant agentic architecture just made their own model optional. The unintended consequence of good engineering. You build something modular enough, and modularity means replaceability. Run that forward. Montreal. Let me make the strongest case for thermos first. 8 million units recalled because people stored fermenting food in sealed containers and got hurt when pressure built up. You could argue this is user error, plain and simple. Everyone knows sealed containers plus fermentation equals pressure. Everyone knows you don't leave perishable food in a closed vessel for days. The company made a product that keeps things hot or cold, and consumers misused it. Case closed. Right? Wrong. And the reason it's wrong is the reason this story matters. There is a well-known engineering solution to this problem. Look at any PET bottle you've ever opened. The threading on the cap isn't continuous. It's designed so that pressure vents before the cap fully disengages. Carbonated beverages have solved this for decades. The engineering is trivial. The cost is marginal. One of the commenters on this story pointed out that the recalled models appear to use a cheaper lid design than the non-recalled versions. The company chose to save fractions of a cent per unit on a pressure relief mechanism. And 3 people lost their vision. This is where the bootstrapism lens cuts deep. A pressure relief thread is not proprietary technology. It is not patented. It is not secret. It is public knowledge, available to any manufacturer on Earth. The solution was sitting in the open, free for anyone to implement, and Thermos chose not to. They didn't lack access to the engineering. They lacked the incentive to apply it when a cheaper alternative existed. 3 people are blind now. Not because the knowledge didn't exist. Because a cost optimization removed a safety mechanism that open, shared engineering principles had already solved. The kombucha brewer in the comments who got splattered knew the risk because the fermentation community shares knowledge openly. Burp your bottles, vent your pressure. The collective wisdom of home fermenters understood what a major manufacturer's product team either ignored or deprioritized. When safety-critical engineering knowledge is open and free, The failure is never ignorance. It is the decision not to use what's already known. The tools exist. The knowledge is available. 3 people paid the price for a company deciding that open solutions cost too much to implement. Let's shift gears completely from life and death engineering failures to something wonderfully nerdy. Pause. Reverse engineering hard drives with nothing but a stopwatch. I once spent 3 days trying to figure out why sequential reads on a RAID array were hitting a performance cliff at a specific LBA range. Turned out the logical block addresses didn't map linearly to physical geometry anymore. The drive's firmware was remapping sectors around defects, and the zone boundaries didn't align with what the spec sheet implied. That experience taught me something fundamental. The abstraction is never the reality. And the gap between them is where the interesting engineering lives. The question nobody asks about hard drives anymore is simple. What's actually happening inside? We treat them as black boxes. You send a logical block address. You get data back. But Henry Wong decided to peel the abstraction away using nothing but timing measurements from the outside. Micro-benchmarks as a form of reverse engineering, reading the physical soul of the device through latency pattern. The craft here is extraordinary. By measuring rotation periods down to microseconds, he reconstructs the angular position of every sector on the platter. By detecting discontinuities in sequential access times, he finds track boundaries. By observing the timing difference between switching heads on the same cylinder versus seeking to the next cylinder, he infers platter count. Without ever opening the drive, tens of nanometers of track spacing, hundreds of thousands of tracks, billions of sectors, and he's reading the geometry through a timing side channel. What makes this work remarkable is that older algorithms assumed predictable track ordering. Head switches before cylinder seeks. Modern drives abandon that layout, so the classic Skippy algorithm fails. Wong had to reason from first principles about what timing signatures would survive firmware translation layers. This is the kind of work that reminds you what engineering actually is. Not frameworks, not abstractions. The physical world interrogated with patience and precision. The drive doesn't want to tell you its geometry. The firmware actively hides it behind logical addressing. But physics doesn't lie. Rotation is rotation. Seek latency is proportional to distance. And someone with enough curiosity and a microsecond timer can reconstruct what no spec sheet will reveal. The whole methodology is published. Open. Reproducible. That's how knowledge compounds. This has been your daily tech feed for Hacker News for May 4th, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that rewards curiosity. We'll see you back here tomorrow.